Hi dear children, welcome to today's class. Today we are going to continue exercise 13.3. Sixth question. How many silver coins 1.75 centimeter in diameter? Diameter is given, that is 1.75 centimeter. And of thickness 2 mm. Thickness 2 mm must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter. So we need to find out the number of silver coins in this question. Silver coin, that we will consider it as a cylinder. Okay, silver coin actually that is cylinder. So the diameter of the silver coin is given, or the diameter of the cylinder is given. Okay, cylinder diameter is given, and from this we can find out the radius. Radius is equal to 1.75 divided by 2. 1.75 divided by 2, that is the radius of our silver coin. Now thickness is given. Thickness means the height of the cylinder. Thickness means the height of the cylinder. So by using these two informations, we can find out the volume of a silver coin. Volume of a silver coin that we can find. That is equal to pi r square h. Volume of a silver coin, since this is cylinder, the volume that is equal to pi r square h. Now substitute the values. Pi into 1.75 divided by 2 all square into 2, and this is equal to 154 divided by 320 centimeter cube. Okay, 154 divided by 320 centimeter cube. Next step, we will substitute pi is equal to 22 by 7. In this question, the second figure, that is a cuboid, and we know that the volume of a cuboid, that is LBH. There is no pi in the volume of a cuboid. That's why the volume of a silver coin, we are substituting the value of pi. Otherwise, when we equating that two volumes, we can cancel pi from both sides. Okay, but here in one side we don't have any terms which contains pi. So in the first one, we will substitute pi is equal to 22 by 7. So we got the volume of a silver coin, that is 154 divided by 320 centimeter cube. Now let n coins be melted. Okay, let n coins be melted. Then the volume of n coins, volume of n coins is equal to n into volume of one coin, that is n into 154 divided by 320 is equal to 154 n divided by 320 centimeter cube. This is the volume of n coins. Okay, now just consider centimeter cube and just consider it as equation number 1. Now we are going to find out the volume of cuboid. All the measurements of a cuboid is given. So volume of cuboid is equal to length, that is 5.5, breadth, that is 10, and height, that is 3.5. So LBH is equal to 5.5 into 10 into 3.5. 5.5 into 10 into 3.5, and this is equal to 385 divided by 2. Okay, 385 divided by 2. I will write one more step. 5.5 we can write it as 55 divided by 10 into 10 into 3.5 we can rewrite it as 35 divided by 10. And then this we will get it as 385 divided by 2 centimeter cube. 385 divided by 2 centimeter cube. Put it as equation number 2. Now according to the question, equation number 1 and equation number 2 are equal. Yeah, according to the question, the volume of n coins is equal to the volume of cuboid. So we can equate equation number 1 and equation number 2. (154n) divided by 320 is equal to 385 divided by 2. 154n divided by 320 is equal to 385 divided by 2. That is n is equal to 385 into 320 divided by 154 into 2. N is equal to 385 into 320 divided by 154 into 2. And this is equal to 55 into 160 divided by 22. 55 into 160 divided by 22, and that we will get it as 5 into 80 is equal to 400. Hence 400 coins must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter. Seventh question. A cylindrical bucket A cylindrical bucket 32 centimeter height is equal to 32 centimeter, and the radius of base is equal to 18 centimeter is filled with the sand. This bucket is emptied on the ground and a conical heap. So the second figure here, it is conical heap of sand is formed. If the height of the conical heap is 24 centimeter, find the radius and slant height. Find the radius and slant height. Okay. So here the volume of the cylinder is equal to volume of cone. Volume of the cylinder is equal to volume of cone. Volume of cylinder, what we will get, that is pi r square h. This is equal to pi into 18 square into 32. Pi into 18 square into 32. That is equal to 10368 pi centimeter cube. Put it as equation number 1. 10368 pi centimeter cube. Put it as equation number 1. And the second figure, that is cone, and we are going to find out the volume of a cone is equal to 1 by 3 pi r square h. 1 by 3 pi r square h, and that is equal to 1 by 3 pi into r we don't know, we need to find it. H is given, that is 24, and thus we will get it as 8 pi r square. Put it as equation number 2. 8 pi r square. According to our question, equation number 1 and equation number 2 are equal. Equation number 1 and equation number 2 are equal. So we can equate equation number 1 and equation number 2. By equating that, we will get 8 pi r square is equal to 10368 pi. Equation number 1 is equal to equation number 2, that is 8 pi r square is equal to 10368 pi. Pi we have on both sides, so we can cancel it, and we will have 8 r square is equal to 10368. 8 r square is equal to 10368. Then r square is equal to 10368 divided by 8. that is r square is equal to 1296. R is equal to square root of 1296, and that is equal to 36. That means the radius of that conical heap, that is 36. We need to find out the slant height also. The relation between slant height, radius and height, that is L is equal to square root of r square plus h square. Slant height is equal to square root of radius square plus height square, and that is equal to square root of 36 square plus 24 square. 36 square plus 24 square, that is equal to square root of 1296 plus 576, and this is equal to square root of 1872. This 1872 we can write it as 12 into 12 into 13, that is 12 square into 13. 1872 we can write it as 12 square into 13. This 12 square we can take it outside of that square root, then that is 12 root 13. 12 root 13, that is the slant height of the heap. Therefore, the slant height of the heap is equal to 12 root 13, and the radius is equal to 36. Now, eighth question. Eighth question. A water in a canal 6 meter wide. 6 meter wide. So, width is given, that is 6 meter, and 1.5 meter depth. Okay. Depth is also given, that is 1.5 meter. This we can write it as 15 by 10 meter is equal to 3 by 2 meter. Is flying with a speed of 10 kilometer per hour. 10 kilometer per hour. The speed of flow of water. Speed of flow of water is equal to 10 kilometer per hour. Speed of flow of water is equal to 10 kilometer per hour. We are going to convert that kilometer into meter first. For that we need to multiply it with 1000 meter per hour. This is equal to 10,000 meter per hour. This is the speed of flow of water. Now this hour we are going to convert it into minute. So this is 10,000 divided by 60 meter per minute. 10,000 divided by 60 meter per minute. This is equal to 500 by 3 meter per minute. So the speed of flow of water is equal to 500 by 3 meter per minute. Okay. That is, we know that canal, that is a cuboid actually. Okay. A canal that is a cuboid. The breadth and height of the canal is given. The value of B is given, and the value of H is also given in our question. Now we need to get the length of our canal. Okay, we need to get the length of our canal. Then only we can find out the volume of our canal. Okay, then only we can find out the volume of our canal. In our question, the speed of flow of water is given. Okay, we will take in this type of questions the speed of flow of water, that is the length of our figure. Okay, speed of flow of water, that is the length of our figure. In this question, the figure is a canal and that is of the form cuboid. Therefore, the length or L is equal to 500 by 3. Okay, L is equal to 500 by 3. Now we can find out the volume of water flows in 1 minute from canal. Okay, volume of water breadth is already given in the question, height is also given, and now we need to get the length of our canal, that is actually is equal to the speed of flow of water. So volume of water flows in 1 minute from canal, that is equal to volume of cuboid, it is equal to LBH, volume of cuboid, that is equal to LBH, and it is equal to 3/2 into 6 into 500/3, 3/2 into 6 into 500/3, 9 into 500/3, 9 into 500/3, that we will cut it as 1500, 1500. Okay, this is the volume of water flows in 1 minute. Okay, here we are considering minute, that's why the hour we converted it into minute. So volume of water flows in 1 minute from canal is equal to volume of cuboid, actually that we will get it as 1500. Now in our question, how much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? How much area will it irrigate in 30 minutes? Okay, so next we are going to calculate the volume of water flows in 30 minutes from canal. Okay, 1 minute, that is 1500, then 30 minutes, that is equal to 1500 into 30 is equal to 45000, 45000. Put it as equation number 1. Now the relation between area and volume. Okay, the relation between area and volume, that is actually, what is volume? Volume is length into breadth into height. Okay, length into breadth into height. What is this length into breadth? That is actually area. Length into breadth, that is actually area, right? So this volume is actually area into height. Volume is actually area into height. So the relation between volume and area, that is volume is equal to area into height. Okay, so in second part the height is given. Okay, in second part, standing water means the height is given, that is 8 centimeter. Okay, height is given, that is 8 centimeter. All other informations are in meter, so we need to convert it into meter, that is 8/100 meter. Now the volume of water flows in 30 minutes, that is actually is equal to the volume of water irrigating the required area. Okay, so volume of water flows in 30 minutes is equal to volume of water irrigating the required area. Volume of water irrigating the required area. Required area. Volume of water flows in 30 minutes, that we know 45000 is equal to volume of water irrigating the required area. In second case we know the height, but we don't know the length and breadth. But length into breadth, that we can write it as area. So that is area into height. Volume, the relation between the volume and area, that is a volume, we can write it as area into height. That is area into height, that is area into 8 by 100. Area into 8 by 100, and thus area is equal to 45000 into 100 divided by 8, that we will get it as 562500. 562500, okay, meter square. This is the area will irrigate in 30 minutes if 8 centimeter of standing water is needed. Ninth question. A farmer connects a pipe of internal diameter. Pipe, we will consider it as a cylinder. The diameter is given. Diameter is equal to 20 centimeter. Then radius is equal to 10 centimeter. From a canal into a cylindrical tank in her field, which is 10 meter. Cylindrical tank, okay, which is 10 meter in diameter. Diameter is equal to 10 meter. Then radius is equal to 5 meter and 2 meter deep. Okay, so depth or height is equal to 2 meter. If water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? That is our question. We need to find out the time. So cylindrical pipe, okay, first we will consider the cylindrical tank. All the informations related to that cylindrical tank is given, because radius is given and the height is also given. So we can find out the volume of that cylindrical tank. Okay, so volume of cylindrical tank is equal to, volume of cylindrical tank is equal to pi r square h, and this is equal to pi into 5 square into 2. It is equal to 50 pi meter cube. 50 pi meter cube. Put it as equation number 1. Now one more information is given in the question, that is a rate of flow of water. Okay, rate of flow of water. It is equal to 3 km per hour. Okay, 3 km per hour. So first we are going to convert this kilometer into meter, because those informations are given in meter. So that is 3 into 1000 meter per hour. That is 3000 meter per hour. And now we are going to convert it into minute. That is 3000 divided by 60 meter per minute. It is equal to 50 meter per minute. It is equal to 50 meter per minute. As I said in the last problem, this we will take it as the length of the pipe. Okay, that speed we will take it as length. So the length of the pipe through which the water flows in 1 minute is equal to 50 meter. Okay, 50 meter. The radius, that is 10 centimeter. We need to convert it into meter. That is 10 by 100 meter is equal to 1 by 10 meter. 10 by 100 meter, that is equal to 1 by 10 meter. So the volume of water that flows per minute, therefore volume of water flows per minute is equal to volume of pipe. Okay, volume of pipe. pipe that is of the form of cylinder, so pi r square h, that is pi into 1 by 10 all square into 5. Pi into 1 by 10 all square into 5, that is equal to pi by 2. We will get pi by 2 meter cube. Put it as equation number 2. Okay, equation number 2. Now if we want to find out the required time, okay, that required time is equal to volume of the cylindrical tank divided by volume of water flows per minute. Okay, time is equal to volume of cylindrical tank divided by volume of water flows per minute. Volume of water flows per minute, that is our equation number 2. The first one is our equation number 1. So that is 50 pi divided by pi by 2 is equal to 100 minutes. Okay, 100 minutes. Hence the tank will be filled in 100 minutes.